Welcome back to the Deep Dive. Today, we are opening a file that, at first glance, looks like it belongs in a dustbin from the 19th century.
Right.
But once you get past that title page, it turns into something that feels more like a sci-fi blueprint for, the next 100 years of physics.
Yeah.
It is a wild ride.
It really is a strange mix. We're looking at a stack of documents dated just recently, February 17th, 2026.
So brand new.
Exactly. And it's got technical notes, a whole folder of Python scripts, and some very complex 3D renderings from a Blender add-on. And the title is The Michelson Interferometer of Spacetime.
Which refers to the Michelson-Morley experiment. And I have to be the skeptic here right off the bat.
Oh, for it.
Why are we digging this up? It's probably the most famous failed experiment in history. We all know the ending to this story. They looked for the ether, they didn't find it, and, well, Einstein gave us relativity. Case closed, right?
That is the standard textbook narrative, absolutely. Yeah. But this source is arguing that we've been reading the ending of that story wrong for over a century. The argument here is that the null result, the fact that the experiment found nothing, wasn't a failure of the machine. It was a failure of our geometry.
Okay, that's a bold claim.
Yeah.
So the premise is that we've been using the wrong map to look at the territory.
It's exactly that. The source makes this big distinction between two ways of viewing reality. There's math space, which is where we've been stuck, and then there's Minkowski spacetime, which is where the physics actually happens.
Wow.
And to really get the difference, we have to look at what Michelson actually tried to do.
Okay, so let's maybe refresh everyone's memory on the basics. This was the setup with the mirrors and the light beams, right?
Imagine a heavy stone table floating in a lab. You have a light source, a half mirror in the middle, and then two arms sticking out at right angles, let's just say north and east.
Okay.
You shoot a light beam, it splits, travels down both arms, hits mirrors at the ends, and then bounces back to the center.
And the whole idea was, if the Earth is moving through space, rushing through this invisible ether, the light going forward into that wind should take longer to get back than the light going sideways.
Precisely. The source uses the swimmer analogy. If you swim upstream against a current and then back down, it takes longer than swimming across the current and back. So naturally, physicists expected the light beams to arrive out of sync.
But they didn't. They arrived at the exact same time.
Every single time, no matter how they turn the table, no matter the season. And this drove physicists crazy.
Because in just normal 3D geometry...
What the source calls math space.
Right. In math space, that makes no sense. If you do the math on a piece of paper using, X, Y, and Z coordinates, the numbers just don't add up. The time should be different.
They should.
So how did physics fix it? Because we didn't just throw away the math and go home.
No, we patched it. We invented length contraction. We basically said, well, okay, maybe the arm of the machine that's moving forward physically shrinks.
Wait, the physical matter squishes, like the atoms actually get closer together.
That's the explanation. The Lorentz contraction. You say the ruler shrinks just enough in the direction of motion to cancel out the time delay. So the light has less distance to travel, and the math magically balances out.
I've always found that so convenient. It feels a bit like accounting fraud.
Yeah.
The numbers don't balance. Let's just erase this debt and write a zero.
The source agrees with you completely. It characterizes this as cooking the books. It calls it a mathematical patch just to force the result to fit the expectation.
Okay.
But here is the pivot. The source argues we don't need to shrink the ruler. We just need to stop looking at a 2D map and start looking at the 4D globe.
This is the Mercator projection analogy from the notes, right?
Yeah.
I found this really helpful.
It's the perfect analogy. If you look at a flat map of the world, a Mercator projection, and you draw a straight line from, say, New York to London, it looks like the shortest path on the paper. But if you look at a globe, the real 3D object, you see the path actually curves up towards the Arctic. The map distorts reality because it deletes a dimension. It flattens the curve of the Earth.
And in the case of the Michelson experiment, the missing dimension is time?
Correct. Math space flattens the experiment into 3D. It treats time as just a clock ticking in the corner. But this source wants us to use the God's eye view, the Minkowski spacetime diagram.
And what does that view show?
It shows the entire experiment as a single object stretching through past, present, and future all at once.
Okay, this brings us to the simulation.
Yeah.
Because the source didn't just write equations, they built a Blender add-on called the Relativity 4D Cylinder. Can you describe what I'm looking at in these renders? It's not a flat table anymore?
No. Imagine that interferometer table again. As time passes, it moves up in the diagram. So that round table traces out a long cylinder, what they call a world tube.
Okay, I'm visualizing a pipe stretching upwards and the light.
In 4D, a flash of light isn't a line, it's a cone. It expands outward in all directions over time. So now you have this world tube cylinder, and inside it you have these light cones bouncing around.
And this is where the geometry gets wild. Because if the machine is stationary, the cylinder just goes straight up. But if the machine is moving...
The cylinder tilts, it leans over, because it's moving through space and through time.
Okay, this is the part I really struggled with in the notes. If the cylinder leans, but the light cone itself stays perfectly straight because light speed is constant, how does that intersection even look?
That is the aha moment.
In the simulation, when that light cone slices through the tilted cylinder, the reflection points don't form a circle anymore.
What do they form?
They form a tilted ellipse.
An ellipse. So that means the light actually hits the mirrors at different times.
Yes. This is the critical insight. In that God's eye view, the light has to chase the mirror that's moving away, so it hits that one later, which means higher up the tube.
Okay.
And it hits the mirror moving toward it much sooner, so lower down the tube. So there is a time difference. The math space people were right about the delay, but they were just wrong about the shape it made.
Exactly. There is a coordinate time difference. But, and this is why you don't need to shrink the ruler, the geometry of an ellipse on a cylinder is symmetrical in a very specific way.
How?
The rays bounce off that tilted ellipse and travel back inward. And because of the specific angles of that ellipse, they meet back at the center axis at the exact same point in space-time.
So the null result, the light coming back together perfectly, it isn't magic, it's just geometry.
It's the inevitable intersection of a cone and a tilted cylinder. You don't need to physically squish the atoms of the machine. The contraction isn't a mechanical crushing, it's just a perspective effect of slicing that 4D object at an angle.
That is surprisingly elegant. It implies that for 100 years we've been trying to fix a mechanical problem like, why didn't the machine break or shrink when it was actually just a perspective problem?
Exactly. We were trying to make the map make sense instead of just looking at the globe. The God's eye view shows the structure remains perfect, it's just tilted.
But the source goes even further than just fixing the geometry. There's a section in here that feels almost, I don't know, aggressive. It accuses modern physics of being geocentric.
It's a harsh critique, but a fascinating one. The source argues that by sticking to our camera eye perspective, what we see from inside the lab, we've fallen into this trap. We insist that we are stationary and the universe has to adjust to us.
It reminds me of old astronomers who thought the sun revolved around the Earth because, well, that's what it looks like from the ground.
It's the exact same logical fallacy. The source calls this the slavery of light. We insist that light speed must always measure as c, relative to us, the observer. We make the light the slave of the matter.
But isn't that the absolute core of relativity? That c is constant for everyone. I mean, that's what Einstein taught us.
It is. But the source argues this is a subject-object reversal. It says, light travels at c through the field, the electromagnetic ocean of space-time. We are just submarines swimming through that ocean. The ocean doesn't care how fast the submarine is going.
Speaking of submarines, I want to drill down on that analogy because it really helped me understand the distinction between the math and the physics.
It's a great visualization. So imagine a submarine using active sonar. It sends out a ping, a sound wave. That sound wave travels at a fixed speed through the water.
Right. The water's the medium. The sound speed is locked to the water.
Now, if the sub is moving forward, the sound wave going forward has to travel through more water to get where it's going. The sound wave going backward, though, zips past the hull very quickly. Inside the sub, the sonar operator measures a delay.
Because the sub is moving relative to the water. Simple enough.
Exactly. Now, applying this to light, the source identifies 3 types of velocity. First, you've got ground speed, your speed relative to Earth. Second, airspeed, your speed relative to the air. And third, field speed.
Field speed. The velocity relative to the fabric of space-time itself.
Yes. And standard physics says you can't measure that. It's impossible. All motion is relative. This source says not only is it possible, we see the evidence of it every time we use a solar sail.
This is the smoking gun argument in the documents. I think most people have heard of a solar sail. It's using light to push a spacecraft. But explain the connection here.
Okay, so a solar sail works because light carries momentum. It physically pushes the sail. But here's the key bit of physics. If you are an atom moving toward a light source, you are blue shifting, you get hit harder. There is more energy transfer.
Like running into a stream of water versus running away from it. If I run into the hose, I get soaked harder.
Exactly. And if you're moving away from the light red shifting, you get hit softer.
Yeah.
So the source argues, if the impact force changes based on your speed, then your speed relative to the field is real. You can't just say all motion is relative when the energy transfer is absolute.
That's a heavy point. If I get smashed by a photon harder just because I'm moving, that implies I am moving as a definitive state, not just, a relative opinion.
Right. It suggests Einstein's setting, that c is constant for everyone, is a mathematical convenience that ignores the physical reality of the smash. It ignores the transfer of momentum.
So, okay, if we accept this, if we accept that field speed is real, how do we find it? The source talks about reverse engineering our place in the universe.
This goes back to the radar geometry concept. The source says that what we call distance is actually a derived calculation. The primary data points we have are time and angle.
Like deflection shooting in combat.
Yeah.
Leading the target.
Exactly like that. When we look out at the universe, we are the camera eye. We only see the light coming back. But remember that elliptical reflection in the world tube we talked about?
The tilted ring, yeah.
That tilt represents information. It's an asymmetry. The source claims that if we analyze the slight differences in timing and angle the drift, essentially, we can reverse engineer the shape of that ellipse.
And if we know the shape of the ellipse,
we can calculate the tilt of the cylinder, and if we know the tilt, we know our absolute velocity through the field.
That is mind-bending. It means we aren't just floating in some relative void where motion is meaningless. We have an instrument panel. We just haven't been looking at it.
Or rather, we've been looking at the instrument panel, seeing the needle move, and then adjusting the dial to force it back to zero because our theory says it must be zero.
That's the geocentric trap again. We cook the books to make ourselves stationary.
It is. We've been piloting the plane by looking at the ground and completely ignoring the airspeed indicator. The source is pleading with us to look at the geometry of the air, the geometry of the field itself.
A compelling argument. I mean, it takes something incredibly complex and turns it into a geometric certainty. It makes the null result of Michelson-Morley feel less like a failure and more like a proof of a 4D structure.
I think that's the key insight. We tell ourselves these stories to make the universe fit our intuition. I am stationary. The ruler shrank. But the universe is usually grander and simpler than our stories. It's just geometry.
So, what's the takeaway for you listening at home? We've gone from 1880s mirrors to 2026 blender scripts. How should this change how you see the world?
I think it's about perspective. The next time you look in a mirror, realize you aren't just seeing a flat reflection. You are the endpoint of a time tube stretching back into the past.
And that reflection you're seeing is a slice of a 4D ellipse.
Exactly. The light that hits your eye had to travel through that 4D geometry to get to you. And if the source is right, if we start forcing the math to fit us and start fitting ourselves into the geometry, who knows what else unlocks?
The source drops a little hint at the end about quantum mechanics, which I thought was a bit of a tease.
Just a tease, but a potent one. The implication is there. If we stop being geocentric about light, maybe the weirdness of quantum mechanics is just another perspective error. Maybe the uncertainty principle or entanglement are just other forms of geometry we haven't visualized yet because we're looking at the wrong map.
Well, that is definitely a deep dive for another day. I want to thank you for guiding us through this space-time cylinder. I feel like I need to go draw some diagrams on my wall.
It was a pleasure. It's always good to check your airspeed.
And thank you for listening. Keep looking up, keep asking questions, and remember, you might be moving through the field faster than you think. We'll see you next time on The Deep Dive.